Good morning. Okay, so what we're going to do today is the second half of the algebraic expressions lesson. The first half was just a review of multiplying, adding, and subtracting polynomials. Today we're going to look at factoring different types of polynomials and some special cases that arise. We did all of this last year, so if you still have your Algebra 2 notes where we factored special cases like sum and difference of cubes or difference of squares, that's what today's lesson is. So before we get into that, here are just some common types of problems that we could have. These are actually multiplication ones, so they're what you did last class. But if I multiply two binomials, one plus and one minus, where all the factors are the same, my resulting answer will be the first factor squared minus the second factor squared, or the first term squared minus the second term squared. Okay, so that's our difference of squares special case in the multiplication format. We'll look at it in the factoring format as well. If I go ahead and multiply the same binomial by itself twice, you can see how that plays out here. This is stuff that you've done before, so that's nothing new. It is important to note that not all of your answers are going to be polynomials. So for example, because I had a c in the denominator or a variable in the denominator, that's the same as taking c to the -1. You can't have negative or fractional exponents when we're talking about polynomials. So just a side note, this answer is not technically a polynomial. So here's another one. If I cube it, that just simply means I'm multiplying this binomial by itself 3 times. And as you can see, it takes a whole lot of time, but the resulting answer is fairly nice. I suggest if you ever have to cube a binomial like this, you take it 2 factors at a time. So if you notice, I FOILed out these 2 factors first, reduced, and then multiplied my answer by that 3rd factor, and then went ahead and distributed. So now let's look at factoring polynomials. So there are special cases, the difference of 2 squares. So if my first term is a square and my second term is a square and there's subtraction happening, that means this factors into 2 binomials or 2 polynomials with 2 terms each. It's going to be the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. Okay, so every time you have a squared first term and a squared second term, and they're being subtracted, and those are your only 2 terms in the polynomial, that can always factor into the plus and the minus. Then we have difference of 2 cubes, so it's the same process. If the first term is a cube and the second term is cubed, so if both of these are being taken to a power of 3, or if you notice that this is a number that has a nice pretty cube root, then it factors into the cube root of my first term minus the cube root of my second term times, and then we take the square, so basically the first term factors that are left, and then we multiply these 2 together and take the opposite sign, so plus first term times second term plus my second term squared. Okay, so again, we're just taking what's left of the first term, what's left of the third term, or second term, sorry, and then putting these 2 together with the opposite sign. Same thing applies for sum of 2 cubes, except this first factor is going to have a plus because it follows the sign that's in my original problem, which means it's a minus in the middle term on my second polynomial. And then here's some examples of what that could look like. Again, we did this last year, so if you need some extra review, Khan Academy has some wonderful videos. I will try to link those on the agenda page. So here are just some examples. All of your homework today is just factoring. Okay, so sometimes factoring looks like just pulling out some terms that all of my terms have in common. So like if everything has an x in it, I can pull an x out. Sometimes it's going to look like factoring like these, and sometimes it's going to look like factoring a quadratic, which is what we've done a lot of. So that would be rainbow method, or that could be, I wouldn't do quadratic formula just because we're not doing it, but that's a great way to check. okay? So here's an example. If I have 21r squared minus 49s squared, well, I notice automatically that this is probably going to be a difference of squares because r squared and s squared are clearly squares. And then 25 I know has a nice pretty square root, and 49 also has a nice square root. So I just went ahead and rewrote these terms with an exponent of 2 on the outside, so it makes it a little more obvious. So 25r squared is the same as 5r all squared, because 5 squared is 25 and r squared is r squared. Same thing on the 49s squared. I went ahead and took the square root of both of those terms, and I get 7s squared. Again, 7 squared is 49, s squared is s squared. So I didn't change my values at all, I just showed them in a different way. Now it's very clear that this is a difference of squares, and I know this factors into my first term, or the square root of my first term, plus the square root of my second term, times the square root of my first term minus the square root of my second term. Here's another example. I just went ahead and re-represented it. So 81x to the fourth is the same as taking 9x squared all squared. Y to the fourth is the same as taking y squared squared. Oh, there should be a square out here. And that's equal to, again, difference of squares. So when it factors, it is the square root of my first term plus the square root of my second term times square root of my first term minus square root of my second term. Here's another example. You're not going to see any like this on your homework, but you could re-represent this in the exact same way. So 16x to the fourth becomes 4x squared all squared. This is already set up to be a nice pretty square. So when I factor it, it's the square root of my first term plus the square root of my second term. Even though my second term has a plus or minus in it, it still works the same way, times the square root of my first term minus the square root of my second term. Here's a sum of cubes example. So I have a cubed plus 64b cubed. I want to go ahead and rewrite these all with an exponent of 3 outside because it makes it more obvious to see what's happening. A cubed clearly is just a cubed. Cube root of 64 is 4, and then cube root of b cubed is just b, so I can rewrite that as 4b cubed. Now it's more obvious that this is a sum of 2 cubes, so when I factor it, I take the cube root of my first term plus, because this is addition, so plus the cube root of my second term times what's left of my first term, so I just took away one of the a's, which leaves me with 2 left. Put these two together and take the opposite sign, so it becomes 4ab, but it's minus for my middle term right here. And then I take this, and I take what's left, so I square it, and it becomes 16b squared for my third term. Here's another example where we can just rewrite it. So c to the 6th becomes c squared cubed. 8 becomes 2 cubed. 27 becomes 3 cubed, and d to the 9th becomes d cubed cubed. And then I just go ahead, and this is a difference of cubes. So I know my operation in the first parentheses is going to be subtraction, and my operation in the second parentheses for that middle term is going to be plus because it's the opposite. So this becomes 2c squared because that's the cube root of my first term, minus 3d cubed because that's the cube root here, times what's left, so we take this and square it, 4c to the 4th. We take this and square it, and that's our third term, so 9d6. And then our middle term is just this times this with the opposite sign. So 3 times 2 is 6, c squared d cubed, and it's plus. So that was really the hard part. Now we're going to go ahead and look at just factoring quadratic polynomials because, we've done that a lot. I just went ahead and rewrote the steps for how to rainbow. So when there's a number in front of our x squared or y squared or m squared that is not a 1, how we would solve it. Okay, but here's an example as well. So I have 12x squared minus 36xy plus 27y squared. First thing we do is we pull out a common factor, so something that's in all 3 of the terms. I pulled out a 3, which left me with 4x squared minus 12xy plus 9y squared. Now I can go ahead and multiply this leading coefficient into my third term. I know some of you are probably getting a little confused because I have x's and y's here. That doesn't change anything. It's still solved the exact same way. It just means that when I go ahead and factor it, each factor will contain an x and a y, but that's no big deal. So I go ahead and rainbow the 4 down. Then it becomes x squared minus 12xy plus 36y squared, because 9 times 4 is 36. I went ahead and made my multiplication addition table. So I found my terms that multiply together to get positive 36 and add together to get a negative 12, because that's what I needed here. And that's negative 6 and negative 6. So the 3 stays outside because that's the common factor I pulled out, sorry. And my factors become x minus 6y, because I have a y squared here, so I have to have a y in these terms, times x minus 6y. Then I can go ahead and unrainbow, which means I have to divide out this number that I multiplied. So it becomes x minus 6/4 y and x minus 6/4 y. I go ahead and reduce that to 3/2. And then we never leave fractions in our factors, so I multiply the 2 over with the x, or bring the denominator up and keep it all in one level. So this becomes 3 times 2x minus 3y times 2x minus 3y, which I can rewrite as 2x minus 3y squared, because they're the same factor, and then times 3. Here's another example. So I have 4x to the 4th y minus 11x cubed y squared plus 6x squared y cubed equals, and then I went ahead and pulled out a common factor to all of these terms. Here I couldn't pull out a number, but I noticed that each of my terms contains an x squared at least, and they all contain a y at least, so I take those out. And that leaves me with 4x squared minus 11xy plus 6y squared. This is a quadratic because this is a squared term right here. I do have a coefficient that I need to multiply down, so I do that, and I'm left with x squared minus 11, this should have a y in it too, plus 24y squared. I go ahead and factor that out using my nice little table, so I get negative 8 and negative 3. So this becomes x squared y, because that was our common factor, times x minus 8y and x minus 3y. I go ahead and unrainbow this 4, so I have to divide it out of both of these terms. So I get x minus 8/4 y and x minus 3/4 y. I go ahead and reduce the fraction, so this becomes a 2. And then this can't reduce, so I kick the 4 over with the x. And I'm left with what I pulled out at the beginning, so the x squared y, times my factors, x minus 2y, 4x minus 3y. So the last way that we can factor is called factors by grouping, and it just means that I'm going to put together terms that I can pull a common factor or variable or number out of, and hopefully when I pull those common factors out, what I'm left with matches what I'm left with in the second grouping as well. So most of the time they're already going to be pre-grouped, so I'd put the first 2 terms together and the second 2 terms together. However, that's not always true. So here's an example. I have 4ac plus 2bc minus 2ad minus bd. So I notice that both of these 2 terms right here contain a c, and both of these 2 terms right here contain a d. So I'm going to group them that way. So I just put parentheses around my groupings to show. I went ahead and pulled the negative out of both of these terms and stuck it out front, which changed the minus bd to a plus bd. Now that they're grouped, I go ahead and pull out their common factors. So not only can I pull a c out of these 2, but I can actually pull a 2. So I pull a 2c out, and I'm left with 2a plus b, minus, I go ahead and pull the d out of these 2 terms, and I'm left with d times 2a plus b. Oh, look, this 2a plus b matches this 2a plus b, so that's my first factor. And then the numbers or values we pulled out become my second factor. So I pulled a 2c out of the first term and a minus d out of the second term. So it factors into what they had in common and then what was pulled out. I'm running out of time, so I'm going to do the last 2 examples on a second video.